Okay, there have been quite a few questions about how to do this Excel table. So let's go ahead and go over it one more time. Alright, so to find the total time, I'm going to start here by making this cell equal that 0.1 second that we start with. That is the change in between all of those sparks. That is your time between sparks if you are set on 10 cycles per second. And then we could add them all up by hand, or we could make Excel do the calculations for us. So I'm going to do what we had before plus what we just added. And then I'm going to highlight that cell and I'm going to drag that formula all the way down. Now you need to make sure that your cursor changes to the one that has the black plus sign. Okay, now for the total distance, I'm going to do the same thing. I'm going to set the first one equal to that first gap. And then the next one is going to be what I had before plus what was in the current set. And then again, I'm going to take that cell, I'm going to wait till my signal changes, I'm going to drag that down. So down here at the bottom, we've gone about 104, almost 105 centimeters of data. So now remember, you really only need to have 5 to 7 really strong data points by the time we get down to acceleration. So if you don't have a ton of data, don't stress about it just yet. Now the average velocity, remember that that is the change in position divided by the change in time. Now remember, I put D's here because we don't have deltas, that's a special symbol. So I'm going to take that and I'm going to drag that down so we have all of our change in position over change in times right there. Now to get my change in velocity, I'm going to do it with my second term minus my first term. And I'm going to drag that down. That'll find the difference between each of those individual terms. My acceleration is going to equal my change in velocity over my change in time. That is an average velocity. You notice it stays kind of consistent and then things get a little weird over here at the bottom. So what graphs did I need to make? I needed to make total time versus total position. So if I go to total time over total position, and I have a scatter plot, obviously you're going to want to add axis titles and give this chart a name. Now if you are in Physics C, you will also want to add a trend line. Now this is not a linear, this is a polynomial, order 2. And this is only if you are in Physics C will you need to have this. Again, if you want to make sure these charts are printable, you can copy them over to a Word document and they'll stay nice and small so they can fit into your lab notebook. Now I also need the velocity versus time. I'm going to insert that. And again, I need to have my axis titles. This should have units included. And this, if you're in Physics C, would be a linear trend line. And you are going to want to display the equation and to display the r² value. The last graph that we need to make is acceleration versus time. Now guys, this is where I've been talking about we need to make sure we have just a good 5 to 7 data points, because our car, as awesome as it is, did slow down. So let's go this again. So we're going to go here and here. There we go. Now you'll notice that it does show that slowing down, but it is somewhat linear up here at the very top. So what I'm going to do is I'm going to take out those last 2 data points. Now you see how it's all spread out and it does not look anything close to what we would expect if I click right here and I go to Axis Options, the minimum, I'm going to set that at 0. And look what happens to that graph. It looks a lot more linear now. So I'm going to add a trend line. Yes, I do have a slight negative slope. It is a linear trend line, and I need to display that equation. Again, trend lines are for Physics C. Make sure your axes titles include units, and bring me questions if you got them. Okay, I'll see you guys in class on Tuesday or Wednesday.